In this video, we'll be going over investigation 8.4.2. So here's a couple of quick warm-ups. In the last investigation, we talked about the two formulas for a circle. We have the area of a circle and the circumference of a circle. The last investigation went over the proof of why these equations are the way they are. But here, if you don't know, the area of a circle is the formula pi r squared. And the circumference of a circle has two forms. You can either do 2 pi r, and we know that 2 radius is the same as the diameter, so you can also think of it as diameter pi. So these are just formulas that we have to know for parts of a circle. So here we're trying to find the circumference. Remember, looking back, circumference is diameter pi. So let's put diameter pi. And in this case here, the diameter is going to be 10. So we're going to delete the input 10.
Please report to Dr. K's office. Thank you.
Sorry about that. All right, here we have just starting circumference, so that's going to be diameter pi. But here, 6 isn't the diameter, 6 is the radius. So to get the whole length across, 6 plus 6, the diameter is actually going to be 12, because the diameter is the length across, 12 pi. All right, 1 more is asking for the area. So the area is pi r squared. And here we know that the radius is 8, so I'm going to replace 8r with 8. So pi 8 squared. Or you can think of 8 squared as 8 times 8, which is 64. So you can think of this also as 64 pi. All right, here the area of the equation is pi r squared. Pi r squared. And again, it looks like this whole thing is the diameter. So the whole diameter is 8, but again, the formula is only asking for radius. So the radius is just half of the segment from the center to the edge. The radius is right here. So the radius of this one is actually 2. So pi 2 squared. Oh, sorry. The radius is 4, sorry. Pi 4 squared. Half of 8 is 4. Pi 4 squared, or you can think of this as pi 16. Okay. Moving on. So in this investigation, we're focusing on what are arcs and what are sectors of a circle. So here, can we divide these into 4, 6, 8, and 5 equal parts? So I like using the line tool. It makes it a little bit easier to draw straight edges. So here we divide it into 4 segments. Here we're dividing into 6 segments. Let's do here and here. All right, dividing into 8 segments. Let's switch to green. 1, 2. Cut this in half. Cut this in half. And divide this into 5 parts. Close enough. All right, so the whole point of this exercise is to see that in order to get equal parts of a circle, we're always starting from the center and radiating out. So using our radius to extend these different lines. So again, to get even parts around the circle, again, we start from the center, and we can cut off little chunks that look like this. Okay. So now let's go and see what are percentages of the highlighted part. So notice that here we have 1, 2 highlighted sections out of the 4. So 2 out of 4. Or 0.5. What's 0.5 as a percent? That's 50%. Okay, here we have 1, 2, 3, 4 out of 6. So 4 out of 6. That's 0.666667, which rounds up to 66.6% or 66.7%. All right, down here we have out of 8 segments, there's 1, 2, 3, 4, and 5. So 5 out of 8, 5 divided by 8. 0.625, so that's the same as 62.5%. And finally, we have 2 out of 5, 2 out of 5, which is 0.4, and 0.4 is the same as 40%. Okay. So thinking about portions of a circle can help us understand the idea behind radius and, arcs and sectors. And one way to look at that is by looking at this pizza example. So here, let's read the situation. To celebrate their victory, the girls' ice hockey team goes out for pizza. Here we have a pizza that has a diameter of 20 inches, so 20 inches across. what's the area of the pizza in exact form, and what's the length of the crust? So the area of the pizza, we know the area formula is going to be pi r squared. Okay, and we proved these in our last investigation. And the circumference, the outer edge, that's going to be diameter pi. So now that we have our two formulas, let's go ahead and type in the information. Area asks for a radius. So notice that here, the radius is going to be half of this. So the radius here is going to be 10. And then pi 10 squared, 10 times 10 is going to be 100. Okay. Here, diameter pi, the diameter, the length across is 20. So I'm going to replace diameter with 20. So the equation is, or the answer is, circumference is 20 pi. Oh, quick disclaimer. There were some rounding errors for the answer key. So you might see some X marks on your program. I updated recently for this one, but again, on your old program or your old lesson, you might still see some red check marks, even though the answer is correct. So just be aware that sometimes you might see an X mark, and that's just my fault. There was a rounding error with the answer key. Okay, so again, you might see X's sometimes, but again, on yours, even though on mine it shows a green check mark, it should be the correct answer. It's just that sometimes you might see a red X, and that's because you're using an older version of the lesson. Okay, here, so using what we know before, we know that the area of the whole thing is 100 pi, and the circumference, the crust of the whole thing, is 20 pi. But if I ate half of it, how much is left? What fraction are we going to need of the whole area to get this second?
Hi, may I get Connor McCoy and Peter McCoy to my office? Thank you, they're going home.
Okay, so if I want half of this circle, I can multiply the whole thing by 0.5. All right, I want 50% of what's there. And if the whole crust goes all the way around, if I want half the crust, I can multiply this by 0.5. So this is what it means to get a percentage or a fraction of the whole circle. Again, I don't want the whole circle. This part's the whole circle. I just want half of it. All right. So again, this is the whole circumference, and I just want half of it. Okay. So Sonia picks a slice from a different pizza. This pizza is only a 16-inch, and her slice has a central angle of 45 degrees. So this part of the pizza represents how much of the whole thing. Do you remember how many degrees are in the full circle? So we know a full circle is worth 360 degrees. Oops, that should go on the bottom. And right now we only have 45 out of 360. You can think of this fraction as like a percentage or a portion of the whole thing. We only have 45 out of 360. Think back to the other example where we did percentages. This is a percent of the entire 360 circle. So now that we have a percentage, let's figure out the whole thing and then use our percentage. So we know that the area is pi r squared, that's our formula. And we know the circumference is diameter pi. So here, the radius, the half length is going to be 8, so pi 8 squared, or 8 squared is going to be 64. And here the diameter is 16, so 16 pi. This would be the whole circle, so the whole area would be 64 pi. But I only want a fraction of it. So I'm going to multiply by the fraction. I only want one slice, one fraction of it. And here again, I know the whole thing would be 16 pi, the crust. But again, I only want a fraction of it. All right. So again, some of yours might come out with a red X, even though this is correct. You're using an older answer key. Okay. So here we have a fraction of the whole thing. So again, this is the whole area, and we're just multiplying it by a fraction. All right, let's go and do this next one. This one is 72 degrees out of the full 360 circle. And so if I already know what the area and the circumference is, again, this is the Goldie's pie pizza. If I want just a section or a slice of it, right, I only want a fraction of the entire thing. So let's copy this. I want a fraction of the entire pizza, and I want a fraction of the entire crust. So again, the whole pizza was 100 pi. I'm just taking this 72 degree section. Again, 72 out of 360. This is a percentage or a fraction of the whole pizza, right? And this is a percentage or a fraction of the whole crust, right? The whole crust will go all the way around, but here we're only getting a fraction of it. All right, so let's go over some vocabulary. The outer edge, the crust of the pizza, do you see this green line? This is called the arc of a pizza, right? So again, the arc, you think of it as the crust is the perimeter or the circumference of the pizza. So let's make an arc of 30 degrees. And if this has a radius of 6, what's going to be the length of the arc? So again, arc involves circumference. It's the outside layer. So circumference equals diameter pi. That's our formula. And this one, the diameter, the length across, if this is 6 and 6, the whole diameter is 12. So 12 pi. And I don't want the whole thing. I just want this little green section. So I don't want the whole thing. I want 30 degrees of it out of the whole 360. So again, this is just our regular formula. And here we just want a fraction of the entire thing. All right, moving forward. Here, let's create a 20-degree arc. So the space that's inside of a circle, part of a section, we call that a sector. So you can think of the sector as a slice of pizza. So notice as I move the green dot, here we have a bigger slice of the pizza, smaller slice of the pizza, right? The whole pizza would be 360 degrees, but we only want a small portion of it, right? We want a 20-degree part of it. So let's go to 20 degrees, okay? And so if the whole radius is 10, what's the area of just this purple section, not the entire thing? So the entire thing would be pi r squared. All right, in this case here, r is 10, or radius is 10, pi 10 squared. And 10 squared, 10 times 10 is going to be 100. So that's the entire thing. So the whole thing would be 100 pi. So this whole purple part would be 100 pi. But I don't want the entire thing. I just want this little segment of it. I just want this section of it. So again, if this is the whole thing, I want a 20-degree section out of the whole 360 degrees. So I'm having a fraction of my entire pizza. Okay. So let's make sure we're understanding. Again, the outside perimeter, part of the perimeter, not the whole thing. This is called an arc. This is called the arc, right? It's not the entire circumference. It's just part of the circumference. And the sector is like a pizza slice. It's the part of the area, not the entire area, just a section of the area. So this is a sector. This is also a sector. Okay, I like that. Just a few more. Okay, moving on. So using what we know, let's go and write a general formula. It's difficult to write theta, so we're going to let t represent theta. And notice that if my theta changes, right, I'm going to refer to different parts of the circle, right? So again, if theta is 98, I'm referring to this sector and this arc. If theta is 233, I'm referring to this section and this arc. So depending on what theta is, it's just encompassing more or less of the entire circle. So the ratio for this would be theta t over 360. And the formula, normally area would be pi r squared. But we don't want the entire pi. Again, we don't want the entire circle. This whole thing would be pi r squared. If we want just a section of it, we're going to multiply that by this fraction. So that would be our formula for a section of the entire circle. So now that we know that, let's go and answer some questions. First, what's the length of the arc? So again, this green part is going to be the arc. So what's the length of arc D and arc E over here? So let's see. We know this is going to refer to circumference. Okay. We know the circumference formula is diameter pi. That's our formula. In this case here, the diameter, again, the radius is 6. The whole length across would be, sorry, the diameter is 3. The whole length across would be 6. Right? And here, the radius is 5, but the whole diameter would be 10. So the diameter across would be 10. So using our formula, this is going to be 6 pi, and this is going to be 10 pi. But that would be the circumference for the entire portion. We only want a fraction of it. We want a 30-degree fraction out of the whole 360 degrees. So we're having a fraction of the entire thing. So here we have a little section of the arc. And here we want a little section of this arc. So again, if the whole thing is 10 pi, we just want a fraction of that arc. Okay. Let's go to the next one. What's the area? We know the area formula is pi r squared. All right. Area is pi r squared. Okay, and so here we know the radius. This radius is 3, so pi 3 squared, or 3 squared is 9, pi 9. And here this is pi 5 squared, the radius is 5. Or we know that 5 squared, 5 times 5 is 25. All right, but we don't want the entire thing. We just want a section of it. We want a 30-degree section of the whole area. So that's just going to be this gray part here. And we want a 30-degree section of this area, which is going to be this gray part here. So again, this part in the front, this is the entire circumference, the entire area. And we don't want the whole thing, we just want a fraction of it, a percentage of it. So notice that we're multiplying by just a fraction of the whole thing that we want. Okay, so let's go ahead and find this one. Find the length of the marked arc. So this arc here, again, we know that circumference is diameter pi. In this case here, the whole diameter, if this is 5, the whole thing across is 10 pi. And I don't want the whole thing, I just want a 70-degree segment. So 7 degrees out of the whole 360 degrees. So this is the whole circumference, and we just want a fraction of it. All right, the area is pi r squared. All right, what's nice about this one, we already know r. R is 5, so we'll erase r with 5. All right, and 5 squared is going to be 25 pi. Again, I don't want the whole area, I just want this pizza slice of it. So I'm just going to get a section of that entire slice. Again, sometimes you might see red X marks, even though this is correct. Again, you guys are using an older answer key. Okay. Here, let's try this one. Again, circumference is diameter pi. Area is pi r squared. Here, the diameter, the whole length across would be 6. Here, the radius is 3, so pi 3 squared, or 3 times 3 is 9. And instead of getting the entire pizza, I just want a part of it. I want a 150-degree part out of 360. And here I want a 150-degree part out of 360. Okay, so again, this is the whole thing, and I just want a fraction of it. All right, here, let's see. Our radius is 8, so again, circumference is diameter pi, and area is pi r squared. Again, the whole diameter, the whole length across, if this is 8, again, to get all the way across, we need another one. It's going to be 16 across. Diameter is 16. And here we already have r, so we can use this 8 here. Area is 8 squared, or 64 pi. I don't want the entire circle. Again, we just want a fraction or part of it. So again, I want a 200-degree part out of the whole 360 circle. So again, I don't want the whole thing. I just want a part of it. All right, so what are arcs and sectors? An arc is a fraction of the circumference. The area is a fraction of the, the sector is a fraction of the area, excuse me. Okay. So let's do a few more questions. What is the arc length? So here, this is 120 degrees. Again, 120 degrees out of 360, I want a fraction of it. And we know arc length is diameter pi. In this case here, the diameter, the length across would be 10 across. So there's the arc length. What's the area of this sector? So again, same ratio, same section. But again, this time it's going to be pi r squared. And here we already know r is 5, so pi 5 squared, or 5 squared is 25. All right, what's the arc length for this one? So I see that CD is 6, so the diameter is 6. So diameter pi, 6 pi. And I don't want the entire thing, I just want half of it. So let's do a fraction of half. All right, and here the whole thing would be pi r squared. Again, if the whole thing is 6, this must be 3. Because 3 and 3 make the whole diameter 6. So it would be pi 3 squared, or pi 9. And I don't want the entire thing, I just want half of it. Okay. So, given radius 14, what's the circumference? Again, we know that circumference is diameter pi. In this case here, diameter is the same as having 2 radius, 2 of those arcs, or 2 of those arms. 2 of the arms connect to make the whole diameter. So it can be 2 times 14. Or 2 times 14, you can think of the whole diameter as 28 pi. What's the area? Area is pi r squared. And since we already know radius, I can just replace r with 14. Or 14 squared is the same as 196. Okay. 2 more. So if this is the diameter, what's the radius? Again, circumference is diameter pi. Area is pi r squared. So replacing diameter with 10 pi. Again, half of this would be the radius, so half of that would be pi 5 squared, which would be 25 pi. Okay, and finally here, if we know the circumference, what's the diameter? So if the whole thing is 100 pi, this diameter is actually 100. the diameter is 100, because 100 times pi is how we get all the way around. The radius would be half of this would be 50. And so what's area? Area is pi r squared. And we just figure that r is 50, so I'm going to place r with 50. Oops. Okay, and 50 squared is going to be 2,500. Right, and so those are all of our areas. Again, everything is based off pi r squared, or diameter pi, using the area and circumference. And the only new thing that we're changing is that instead of doing the whole thing, we're just doing a fraction of it. All right, so it's just a continuation of what we did before. All right, if you still have questions, please let me know. And I hope you found this video helpful.